Have you ever felt the wind on your face? That gentle caress, sometimes a playful gust, other times a fierce gale. It's a sensation that connects us to the very essence of our planet. An invisible force, pushing, pulling, whispering through trees. It dances with the leaves, creating a symphony of rustling sounds. It's a mystery that has fascinated us for centuries. Ancient civilizations revered it, poets wrote about it, and scientists studied it. Where does it come from, this wind that shapes our world? It travels across continents, over oceans, and through valleys. It's not magic, though it may seem so. The wind is a result of natural forces at play. Wind is a natural phenomenon, a dance of air driven by the sun and our spinning planet. The sun heats the earth unevenly, creating areas of high and low pressure. Wind is the earth breathing. It's a vital part of our planet's respiratory system. It carries the scent of rain, the chill of mountains, the warmth of deserts. Each breeze tells a story of its journey. Understanding wind is understanding a fundamental force of nature. It powers our weather systems and influences our climate. It is a journey into the heart of how our planet lives and breathes. By studying the wind, we gain insight into the dynamic processes that sustain life on Earth. The story of wind begins with the sun, our very own star. The sun bathes the Earth in light and heat, but not equally. Some parts of our planet, like the equator, receive more direct sunlight. This makes the air near the equator warmer than the air at the poles. Think of a hot stove. The area closest to the heat source gets hottest. Similarly, the equator is like the Earth's hotspot, constantly warmed by the sun's intense rays. This uneven heating is the first ingredient in the recipe for wind. Warm air is like a hot air balloon. When heated, it becomes lighter and starts to rise. It's lighter and less dense than cold air, so it rises. This is a fundamental principle of how air behaves. As the warm air near the equator rises, cooler air from the poles rushes in to fill the space. This creates a continuous cycle. This movement of air from cooler areas to warmer areas is the very essence of wind. Wind is essentially air in motion. Imagine a crowded room with one open door. The air inside is warm and stuffy. People near the door might feel a draft as cooler air from outside rushes in. This is similar to how wind works. The same principle applies to wind on a global scale. The Earth's rotation and temperature differences drive these patterns. The constant movement of warm and cold air creates the invisible currents we experience as wind. These currents shape our weather and climate. Section 4. Pressures push. Air's journey from high to low. We've talked about warm and cold air, but there's another key player in the story of wind-air pressure. Air pressure is the force exerted by the weight of air in the atmosphere. It plays a crucial role in determining weather patterns and wind movements. Areas with warm, rising air have lower air pressure. This is because the warm air expands and becomes less dense, causing it to rise. Areas with cool, sinking air have higher air pressure. Cool air is denser and heavier, so it sinks, creating areas of higher pressure. Air, like most things in nature, seeks balance. This balance is achieved by the movement of air from high-pressure areas to low-pressure areas. It moves from areas of high pressure to areas of low pressure. This movement of air is what we experience as wind. Think of a bicycle tire. The air inside the tire is under high pressure. When you pump it up, you're increasing the air pressure inside. This is similar to how high-pressure systems work in the atmosphere. If you were to open the valve, air would rush out from this high-pressure area to the lower-pressure atmosphere. This is a simple example of how air pressure differences drive wind. The greater the difference in pressure, the stronger the wind. This principle helps meteorologists predict wind patterns and weather changes. Section 5. A spinning stage, Earth's twist, and the Coriolis effect. The Earth is not static. It spins on its axis. This rotation creates a fascinating phenomenon called the Coriolis effect. Because of the Earth's spin, wind traveling long distances appears to curve. In the northern hemisphere, wind curves to the right. In the southern hemisphere, it curves to the left. Imagine rolling a ball across a spinning merry-go-round. To someone standing on the ground, the ball's path would appear curved. This is similar to how the Coriolis effect influences wind patterns, creating the large-scale wind systems we see on weather maps. Section 6. Wind's helping hand, from kites to clean energy. For centuries, humans have harnessed the power of wind. From the simple joy of flying a kite to the complex engineering of wind turbines, wind plays a vital role in our lives. Windmills have ground our grain and pumped our water. Sailboats have traversed the oceans, guided by the wind's invisible hand. Today, wind turbines offer a clean and sustainable source of energy, turning wind power into electricity. Section 7. Nature's Marvel. Unraveling the Science of Wind. The wind is a reminder that we are part of a dynamic, interconnected world. What may seem like an invisible force is actually the result of complex interactions between the sun, the earth, and our atmosphere. Understanding these processes allows us to appreciate the wind not as a mysterious force, but as a natural wonder, driven by the laws of physics. Next time you feel the wind, take a moment to consider its journey. From the sun's warmth to the earth's spin, it's a story written in the very fabric of our planet.